In lesson 21, we are going to be looking at the Triangle Sum Theorem and proving it. So on page 151 in your student workbook, we've got this diagram and it says what went wrong. So there are two lines, L and M, that are not parallel and they've been cut by a transversal. So remember, here's our two lines in question. So this line and this line, and we're saying they're not parallel and they are being cut by a transversal. So remember, a transversal is just the line that goes through them. So here's our transversal. Tyler thinks that angle EBF, so Tyler thinks this angle is congruent to angle BCD. Okay, because they're corresponding angles. So in that kind of same spot. And so thinks that they're congruent and that a translation along the directed line segment B to C would take one angle to the other. Okay, so this is what he thinks. Okay, these two angles are equal. And if we took a translation and just grabbed this angle and translated it down the line, that it would be equal to the other one. So if we just grabbed this, moved it along BC, it would be equal. Okay, so that's what he thinks if we move it there. So we've got 4 statements in the student workbook. So we're going to assign you each group a statement to be looking at. Okay, so statement 1, 2, 3, or 4. And again, these are in your workbook. So statement 1, 2, 3, and 4. And then as a group, okay, you're going to be deciding if each statement is true or false and explaining your reasoning. Okay, and thinking about in what circumstances are corresponding angles congruent, and be prepared to share your answer. So each group will get a different statement and then you'll think about those statements. So you can pause the video, do that, and come back. All right, so thinking about statement number 1, it says the translation takes B to C so that the image of B is C. So when we looked at what Tyler was doing, and he said he wanted to go on the directed line segment BC. Okay, so if we're translating from B to C, will it take B to C? This is true. Will it always take B to C? Yes. Okay, so B to C, that will be the image. Okay, C will be the image of that translation. Number 2, the translation will take E to somewhere on ray CB. So here's ray CB. Let me get ray CB drawn on here. Okay, so here would be ray CB. Is E going to move somewhere along there? And it would need to be translated by a distance greater than BC to land on the other side of C. So E, if we're going from B to C, E is going to move somewhere between here. Okay, the only way it could move to the other side of C is if it had to move further than BC. This is true. Number 3, the image of F. Okay, so the image of F has to land somewhere on line M because translations take lines to parallel lines, and line M is the only line parallel to L that goes through B prime. Okay, so F would have to land somewhere on M because translation takes lines parallel to lines, and line M is the only line parallel to L that goes through B. Well, they're not parallel. Okay, these lines are not parallel. We were told that in that statement above. They are not parallel. Okay, so F is not going to land on M because M and L are not, because M and L are not parallel to each other. So this number 3 is a false statement. Number 4, the image of F call it F prime, has to land on the right side of BC. Okay, so here's BC. So this would be the right side of BC, so anywhere over here. On the right side of BC, or else F prime wouldn't be parallel to the directed segment. So F has to be somewhere over here so that when it gets translated, this directed line is parallel to this directed line, the movement. If F went over here, if F prime went over on this side, this line would not be parallel to that directed line segment. So that would be a true statement. Okay, so let's take a look at statement 3. So statement 3 says it's the only one that's false. Okay, and again, why is it false? Because these lines are not parallel. So line L is not parallel to M. If it was, this would be a true statement. But L and M are not parallel to each other. So what this is getting at is that all those other statements are true, okay? And where this doesn't work, so where the reasoning went wrong here of translating this and these two angles being congruent is that these two lines were not parallel. Okay, if the two lines are parallel, then everything works and you have corresponding angles that are congruent. Okay, so only if these two lines are parallel. So if we have this line, and here, these two lines must be parallel to each other for the corresponding angles to be congruent. Okay, if these are off, okay, if this is not parallel, then that angle is no longer translating down to this one. Because remember, translations have to take lines parallel to themselves. Okay, so in order for this angle to translate down to this one, the lines have to be parallel to each other. So only in parallel lines are corresponding angles congruent. All right, then let's take a look at activity 21.2. There's going to be a lot of stuff to do in this one. So you need tracing paper. And on your tracing paper, you are going to draw, not on your tracing paper yet. So in number 1, draw this in your book. Okay, so draw a triangle in your student workbook on page 152. So draw just any triangle with a straight edge on page 152. So make sure that you use a straight edge. Draw any triangle. This is mine. And then label the 3 angles ABC however you want. Your triangle does not have to look like mine. Then on the tracing paper, I need you to trace this triangle onto it. Okay, so trace the triangle onto your tracing paper. And label the angles exactly the same as they are in your student workbook. Then I need you to fold 2 sides. Okay, so fold 2 sides to find the midpoint. Okay, so if you're going to find the midpoint, if I'm going to find the midpoint of this side, then I would fold this vertex onto this one. So on my tracing paper, I would fold this point onto this one to identify where the midpoint is. Okay, so fold it and find the halfway point. Okay, so that'll find you the exact midpoint. Then do it again for another side. So whatever other side you choose, okay, fold it, find the midpoint. And then label these on your tracing paper. And you can label them whatever letter you want. I'm going to just do M for midpoint and do M1, and then I would do M2 on my other side. So if I'm going to do this side, I would fold this point to this point and then find that middle. Label it on your tracing paper. Okay, so on your tracing paper, so you should have kind of this drawn on your tracing paper. So you should have your triangle redrawn on the tracing paper. So I'm just going to trace this onto here. So here's the original triangle. Okay, these labeled angles. So having A, B, and C labeled on your tracing paper, and you should have your midpoints. Okay, so you have your tracing paper. So if you remove your tracing paper from your, so you have your original triangle, whoops, you have your original triangle drawn in your book, and then you've got the tracing paper that has the labels of the angles and your two midpoints drawn on it. So now what you're going to want to do is rotate your triangle around one of the midpoints. So pick a midpoint, stick your pencil in it, rotate the paper until it makes a new triangle next to it. So again, remember, I can't stick my midpoint when I'm rotating. Okay, but this is what you'll do. You'll keep rotating it until it lines up, okay, with that midpoint side, making a new triangle. Okay, so just like this, so rotate it around until it matches the side with that midpoint. Then draw this new triangle in your student workbook. Okay, so draw this new triangle in your student workbook. So kind of lift your tracing paper up and put those new points down. So then in your workbook, it looks like this. You've drawn that new triangle in, labeling those angles. So this was B prime, this was A prime, and this was C prime. So labeling those angles in there. So you rotated this, okay, got it drawn in your student workbook. So now we're going to do it again. Okay, so take your tracing paper onto your original figure in your book. Now rotate it around your other midpoint. Okay, so now rotate it around your other midpoint. So stick your pencil into the other midpoint and rotate your triangle. Okay, until it lines up next to your original. Okay, creating a new triangle right there. And get that one drawn in. Okay, so now get this new triangle drawn in. Labeling those angles again on your student workbook. So mine was C, really double prime here, A double prime, B double prime. So you should have something that looks similar to this. Again, you don't have the exact same triangle as me, so yours might look a little bit different. So then the final thing is to determine what the value of A, B, and A plus B plus C is. Okay, so look on your picture for somewhere that you see A, B, and C together. Okay, so if you look right here, we can see A, B, and C here making a straight line. Okay, so they line up along this bottom edge of the triangle. So you've got B here. Okay, so you've got B here taking up this angle. You've got A here. And then you've got C here. So altogether, what do they total? Okay, so they total 180 degrees because right here they create this straight line. So together, all three of them total a straight line, which is 180 degrees. Okay, so if you take a look and compare to your neighbors, okay, so compare to the people around you, what's the same in everyone's work and what's different? Okay, and can you see, are there any alternate interior angles to help you with this proof? Okay, so here's one diagram. Okay, and then let me grab mine as well. Okay, so here's one diagram. Here's mine. Let me get some lines drawn on here similar to theirs. Okay, so you can see we've got this line up top. And let me make that dotted like theirs. And then we've got it down here as well. Okay, now my original triangle is this one. Okay, theirs is this one. So do we see anything with alternate interior angles here? So people could have picked a different midpoint, right? So I picked a midpoint here and here. So they picked it of the top two sides. So they picked between AB, okay, and BC. But then we do see that they get this straight line over here, okay, with A, B, and C making a straight line. Where else do we maybe see some alternate interior angles? So if we take a look at this line here, parallel to this one from the translations, you see an alternate interior angle here and here, okay, on opposite sides of this, transversal, okay, here to here, rotating up around that midpoint. And then we also see an alternate interior angle here to here. Let me get a straight line instead. Okay, so we've got this side, and then you've got this angle and this angle being alternate interior angles. So these alternate interior angles will, you know, rotate up every time. So if I had a different triangle, let me just get a different triangle drawn on here. So if we draw this line here, whoops. Okay, if I were to move this up, when I move this alternate interior angle up, this alternate interior angle will go to here. Okay, they're going to be the same. This angle, alternate interior moves it to here. And then you still have the original angle. So all three of these angles in a triangle are always going to total 180. So then if we look at it in a different way, so in this one, it's going to talk about translating. So they want us to translate triangle A, B, C. And they want us to translate it along the segment BC. So we're going to move B to C. Okay, and here's that translated triangle. And then they just want us to label the new triangle A prime, B prime, C prime. And then measure, so label the measures of the angles A prime, B prime, C prime. Okay, so same thing in here would be A prime, B prime, C prime for those angles. Then it wants us to take triangle A prime, B prime, C prime, and now change this one. Okay, now translate this one along the segment from A to C. So translate triangle A prime, B prime, C prime along the directed segment from A prime to C. Okay, so from A prime to C. and label that A double prime. So A double prime, B double prime, C double prime. And then label your angles in here again. So this would be A double prime, B double prime, C double prime. Now label the measures of the angles that meet at point C. So taking a look at these angles that are meeting right here. Okay, so label the angles that are meeting at C. So what would this one be? So we would see vertical angles here. So this one would also be A or A double prime. Okay, but it's going to be the same size as A. This one is going to be the same size as B, and this one is going to be the same size as C. So we end up with those vertical angles, okay, getting A, B, and C to be a straight line again, getting A plus B plus C to equal 180 degrees. So you could do translations in this manner to find the sum as well. Okay, so ultimately the goal here was that we got the triangle sum theorem, which is that all of the angles in a triangle, A plus B plus C, so all three of the angles always total 180. And this can go on your reference chart so that A plus B plus C is always equal to 180. So we could rotate the triangles up and seeing this. So when we rotated this up, we got B here. Rotated this up, we got C here. Okay, equaling out to a straight line of 180. So that gets us a way to see that those angles always total 180. And then also noticing the parallel lines, okay? So understanding that BC is parallel here, so alternate interior angles gets B up there as well. So this would be alternate interior. This would be alternate interior. Okay, so by doing alternate interior, you get this top line parallel, and you can see totals 180 that way as well. All right, so hopefully you are able to prove that the angles of a triangle total up to 180 degrees. You have lesson practice problems starting on page 156. So page 156 to 159.